Let's talk about rocks and minerals. First of all, we have to decide what a rock is. And a rock is kind of a hodgepodge of everything. It can contain organic material, which is things that are made from living processes. It contains carbon. It contains different types of minerals in it. It contains glass. It can contain rock fragments, any other kind of natural materials. So it's a hodgepodge of things. Though most rocks do contain one or more minerals, and there are some minerals that are called rock-forming minerals, and these are minerals that are commonly found in rocks, such as quartz, feldspar, mica, calcite. There are some minerals that are not found in rock as prevalently as these are. Two different types of igneous rocks are intrusive or extrusive rocks. And intrusive, as we know from our past vocabulary words, means that they are created inside the earth, and extrusive is if they are on top of the earth. So the igneous rocks formed are categorized based on where they are formed. So if the magma is below the surface and cools and forms igneous rocks, those are called intrusive igneous rocks. If the magma cools on the surface of the earth and forms a rock, that's called extrusive igneous rock. Magma that cools very slowly produces grains in the rocks that are large enough for us to see with our naked eye, which is important and is on the test. There are three different types of rocks: sedimentary, metamorphic, and igneous. You need to know each type, and you need to know what it is that forms those types. What are the processes? You can refer back to our rock cycle adventure that we did to help you with that. First is our igneous rocks, like our intrusive and extrusive that we talked about. These are formed when magma cools and hardens. You know, magma is deep within our earth, and it rises to the surface because it is less dense than the rock around it. And that is really important. You need to understand why it comes up. And what happens is that magma will come up wherever there is a little nick or cranny or opening in the rock layers, because it's less dense and it's going to want to come up and fill those areas. One source of the creation of this magma, for the heat source that can make it, is the radioactive decay of the elements that were left behind from the formation of the Earth. So you need to know that what it is that causes the magma, and you need to know that it is less dense, and that's what does force its way up. Igneous rocks can be classified based on the type of magma, and there's basaltic magma rocks, and these are created with dark color magma. Their rocks are dense, and they are very dark in color, and this is where we get the black sandy beaches in Hawaii. Andesitic rocks, these have a combination, but a mineral combination that gives them in between. They're not real dark and they're not real light. Granitic rocks are light in color and they have a lower density. So remember BAG, B-A-G, B being dark in color, very dense, and the G of the bag being the lighter color, lower density. First, let's talk about sedimentary rocks. You need to know that they are formed when sediments are pressed together and they are cemented together. And the one thing that cements them together is they are cemented together by minerals that form within those empty spaces. What can happen to form the sediments is you get weathering, which is the breaking down, and erosion, where that is carried away. That can be carried away into different areas that can form the sedimentary rocks in different areas. So to get sedimentary rocks, you have to have weathering and erosion to form sediments. Then those sediments are compacted and cemented together. That's how you get sedimentary rocks. You need to know that detrital rocks are made up from broken down rocks. So those rocks that are broken down by weathering can then form into new rocks that are called detrital rocks. Detrital rocks. Know the difference between weathering and erosion for the test. The next type of rocks that we're going to talk about are metamorphic rocks, and these rocks are changed due to increased temperature and pressure, so they are found deep within the earth, and they can form from other to or even from itself. Pressure from the rock layers above is where they get the pressure, and the temperature, the increased temperature is from the depth of the earth, because we know that it increases as we go down. Metamorphic rocks are classified by what their composition or what they're made of. They're also classified as either being foliated or non-foliated. Foliated meaning layered, and non-foliated meaning not layered. Again, that is on the test. So, what is the rock cycle? And this is the process of which one rock becomes a different type of rock. And I want you to really keep in mind that when we talk about the rock cycle, that this is a cycle that is very, very slow process. We talk about this in class like it happens very quickly, but this is a very, very slow process that occurs over time. And it shows the transformations of the three rocks, like from metamorphic to igneous to sedimentary, and that's what the rock cycle is. It can also be called what we consider to be a matter cycle. All the matter, the law of conservation of matter says that matter cannot be created or destroyed. It can just be transformed or transferred into something else. And any of these things that are in cycles, like the rock cycle and the carbon cycle and those type of things, are cycles where these types of matter are transformed. And so the rock cycle shows how rock can be weathered into small rocks and mineral grains, and then erosion acts on those materials and carries them away by wind, water, ice, and these changes take place in the rock cycle. And these changes never destroy or create new. It's just transforming what was had there. You have to be able to account for all of it. This is a great picture of the rock cycle, and I want you to really understand it. I want you to understand that the blue arrows here are the processes. So everything that's leading up to the big blue arrows, those are the processes that goes into it. So for example, the processes of the sedimentary rock here are the two blue arrows in front, which means we have weathering and erosion, which gives us sediments, and those sediments that get deposited, and then they get compacted and cemented together, and that gives us sedimentary rock. Metamorphic rock, the arrow before that, is heat and pressure, gives us metamorphic rock. Igneous rock, the blue arrow before that, is you have melting into lava or magma, and then it cools off, and it gives us, or solidifies, and gives us igneous rock. Also notice that we have black arrows that go through here, and those black arrows tell us other routes that could happen, so that you need to understand that igneous doesn't always turn into sedimentary. Sedimentary does not always turn into metamorphic. Igneous could also come down here and be put under heat and pressure after it gets buried into the ground. It could make metamorphic. Igneous rocks could also melt and then cool again and become another igneous rock. Or igneous rocks can weather and be buried and become sedimentary rock. So really understand and know this rock cycle for the test. It will definitely be on there.
The rock cycle is a
And that was the video that we listened to in class. And so feel free to listen to that video again. It's a great prediction, a great example of the rock cycle. Next, we're going to go into minerals. What is a mineral? What's different between a mineral and a rock is a mineral, I can write a definite chemical formula for it. It has a definite atomic structure. So what they're made of is things off the periodic table. There are 4,000 minerals found on Earth, and all of these have four major characteristics, and you need to know these four characteristics. Number one, all minerals are formed by natural processes, not influenced by humans. They're inorganic, which means they're not made by life processes. All are elements or have definite chemical compounds, and they are crystalline solids, which means they are solid, they have a definite shape to them. And not all solids are minerals, but all minerals are solids. So if you have a mineral, it must be a solid, and it's a crystalline solid. There are physical properties that we use to ID our minerals, and you can keep going back to our ID lab for this. Some of the properties are color and appearance, hardness, streak, luster, density, cleavage and fracture, chemical activity, and special properties. So let's talk about some of those. Color and appearance obviously is what it looks like. It should not be the number one thing that you use to identify a mineral by any means. Also hardness, that's how easily we scratch it, how easily is it broken, and we measure that on the Mohs scale from 0 to 10. Luster is how it reflects light. Does it look metallic or non-metallic, shiny or not shiny? Specific gravity we won't use in class, but it is the amount of water in the mineral compared to the amount of mineral that's in there. Streak is the color of its powder, and the streak is when we put it on the streak plate. It may look different than the actual color of the mineral when you look at that, so it's very important that you realize that that's the powder, and that is on the test. Next is cleavage and fracture. Know the difference between the two. They were our vocabulary words, and it's how a mineral breaks. A cleavage is when it's breaks on a nice smooth line, and that has to do with how the atoms are arranged. Fracture means it breaks and it's not smooth, and you should be able to remember in your mind how that was on not only our virtual mineral lab, but the one that we did in class. Also, other unique properties that it could have is that are some that are magnetic, which if you have if you have iron fillings, the magnetite will actually pick it up. Next is calcite, and calcite will actually react with hydrochloric acid. Now, also, there's halite, which actually tastes like salt. Looks like calcite, but tastes like salt. Does not react with hydrochloric acid. Adams patterns is how these minerals are put together, and they are crystalline, means that they're arranged in a repeated pattern, which gives it a definite atomic structure. So it is a crystalline solid, means it has atoms that are arranged in a repeated pattern and has a definite structure to it. Crystal systems are sets of crystal systems with similar atomic arrangements. That means their external crystals have a similar shape, but not all crystals have regular shapes or smooth surfaces. We think that, but not all of them do, and that's important to remember. Crystals from magma, as it cools the surface, as it reaches the surface, it cools and it forms crystals. It cools quickly, the crystals can easily be seen by the naked eye. If it cools slowly, the crystals are very, very small and they're harder to see. You can also, so we get crystals from magma, we can also get crystals from solutions. So it's important that you understand how we get both crystals. It will be on the test. What are the two ways that crystals can be formed? By magma, give me the process. Crystals, give me the process. Crystals from solutions, they can form when the minerals are dissolved in water. Then when the water evaporates, the ions that are left behind come together to form the crystals. If a lot of minerals are in a solution, it can begin to form in the solution without complete evaporation. So our borax, that type of thing, is kind of an example of that, of how those crystals can form when the water evaporates. When we make our ornaments, you'll be able to see that. Minerals and compositions and groups. There are 90 elements that occur naturally in the Earth's crust. 98% of the crust is made up of only 8 of these elements, and that's really important. Silicate is one of them. Silicon and oxygen is definitely some of those that are in there. So minerals are primarily made up of those 8 elements. They're not made up of the nickel and the things like that that are deep within the earth and the iron. We have silicates, which is the most common rock-forming mineral and most belonging to this group, and it's really important that you know that. They're made up of silicon and oxygen in one or more element. So for a silicate, you have to have silicon, you have to have oxygen, and one or more element. These forms the building blocks for most minerals in the crust and the mantle of the earth. And that's because most of your crust is made up of this. And so that's what forms those crystals. So it's important that you understand that silicates, which are made of silicon and oxygen, and one is what forms most minerals. All right, that is all of our notes. Make sure you study them all so that you know what you need for the test.